Hey there, friends. We are going to look at 6-3 day one. Even though it looks kind of funky monkey, it is things you already know how to do. You're going to be asked to add, subtract, multiply, and kind of divide, although I would argue that this is really just going to be reducing if it's possible. So you're not going to do any actual division. And it's going to use just function notation. So for example, here it's just telling you this is the rule that we're calling rule F. Here's the rule we're calling G. So when you're doing F plus G, you are literally taking F and then adding G. And I'm putting parentheses around it. It doesn't matter in addition, but that's kind of the only time it doesn't matter. So I use them just to be safe. And then here, really all I'm going to do is combine my like terms. That's how you add polynomials. We've done this kind of all year. So I start with my highest power, which is the x squared, but I don't have any others to combine with it. But in terms of plain x, I have a plus 3 and a plus 5. So I end up with positive 8x. And then for numbers, negative 1 and positive 7 give me a 6. And that is my answer. I do have to be careful over here because this one I'm taking F again, so I'm copying the rule from up above, but now I'm going to subtract this one, and now it does matter because this is like having a negative 1 out front that's going to distribute and change this to a minus 5x minus 7. Now I'm going to go ahead and combine like terms. This is still the only x squared term I have, but now I have a 3x minus 5x, so I get a negative 2. And then a negative 1 and a negative 7 are the two numbers. So minus 1 minus 7 more puts me at a negative 8. So that little subtraction is probably the thing that gets people the most, and that's common on the ACT, which is something a lot of you will be taking. So just kind of watch for that. Now we're going to take a look at what looks like division, but it's telling you to take function f, and they redefine them. Function f is now 6x squared. Put it over function g, which they're now calling negative 3x squared, and then do whatever math you can to that. Well, we did these recently where I would say, oh, well, 6 over negative 3 is going to be a negative 2. And here I have x squared on the top and bottom, so they're the same and they cancel. So in this case, it reduces to just a number. Here I'm multiplying them together, so the f they gave me to work with now is this, and the g they gave me to work with is this. This is not going to be foiling or distributing or anything because I only have one term times one other term. So I multiply the numbers, and then I use the power rules that we studied recently where I add the powers in that scenario. Because keep in mind, x squared is really this, and when you multiply it by another x squared, you end up with x to the 4th. So this is just really a continuation of the exponent rules that we learned earlier. Honestly, I'm not sure why this is broken up, but it's a good first day back from break kind of thing. Here they've redefined my functions again, and I'm going to multiply them again. And the reason they're kind of doing that is up here, this was just one term times one term, but sometimes you have to FOIL, sometimes you'll have to distribute. And the way you know you're going to do that is if you have like plus and minus in the problem as well. You have more than one term. So here to take f and multiply it by g, I have adding and subtracting in the mix. And in this particular problem, because each one has two parts, I'm going to need to FOIL, which we literally have done since Algebra 1. It just looks a little bit different now with this function notation. So first, outside, inside, and the negatives cancel there, making that a positive 15. And then the last is that negative 3 times my 7, which looks weirdly like a 2, sorry. Then these two are alike. So when I'm done, I have negative 10x squared plus 29x minus 21. So all of the math that you're doing is math you have already done. It's just putting that first step in function notation so you know what to do. Once you know what to do, then you just go ahead and do the math you already know. Hope that helps. Bye, guys.